Okay, let's get started on the back of this question sheet. A high jumper has a mass of 35 or 55 kilograms, wishes to jump over a bar. Center mass is 1 meter above the ground, which makes sense because when I'm standing on my feet, I can still fall, even though I'm already on the ground, but the majority of my body is above the ground. So I will have potential energy there. But let's do question 3. We have a high jump situation. It's 1.8 meters tall. This particular jumper is going to be 1 meter off the ground. We can essentially assume that they're square box, 55 kilograms. And they're going to leap over top of there with some sort of kinetic energy to potential energy gain. She wishes to clear the bar at 0.4 meters. Okay, good. We have the velocity here. And then later on, she's going to land on a pad, probably sideways. So we can assume that she's not standing still. And that's only 40 centimeters, so that's 0.4 meters. In this particular question, they didn't give me the velocity at the beginning. So you need both of them. So I can still get E total, but I'm going to be looking at the middle point. E total will be EK plus EG. Looking at the middle point, we got mass, 55, velocity is 0.4 over 2, plus mass times gravity times the height. And we can figure this out. So we got 0.4 squared times 55 divided by 2. That's 4.4 joules of kinetic. It's going to have a lot more gravitational. So that's 970.2. Oops. And then we add those two together. I get 974.6 joules. That's my total for everywhere in the question. Beginning, middle, end. It's just going back and forth between them. So let's take a look at part A. Squeeze it over here. How fast is she going when she leaves the ground? So we got E total equals EK plus EG. And E total we know. Every single part of the question is not going to be the same number. Kinetic energy, I don't know the kinetic energy, but it's mass, 55. And the gravitational, she's 1 meter off the ground. Okay, so let's get the math here. 974.6 equals, I could do 55 divided by 2, 27.5 v squared, and this will just be a number. 55 times 9.8 is 539. That's going to the other side and become subtract. So it's 974.6 becomes 435.6 equals 27.5 v squared. Divide by 27.5, square root that. We get 3.97, so it's about 4. Okay, that's how fast she needs to go to lift off and clear that ramp. She lands on her back on a foam mattress, so she's lying flat now. So we have to just do the same question again. Same setup, exactly the same thing. E total equals EK plus EG. This one is nice and easier though because what speed should she go and hit the platform? Oh, I was thinking she stopped, but no. And she's not on the ground. It's exactly the same difficulty. Okay, that's my E total. It's fixed all the time. Her mass is 55. And now EG is not going to be 1 meter. It's going to be 0.4. So it's going to be 55. 9.8 times 0.4. Same thing as last time. Let's find out what her energy is this time. So she's 55 is 215.6. Okay, so now we're going to subtract that from 974.6 and then divide by 27.5 and then square root that. I get velocity equal 5.3 meters per second. Shortly after she lands, she does come to rest. Okay, then what has happened to the mechanical energy she had at the moments earlier? It would all get absorbed into the foam, and the foam would actually heat up again. So yeah, it's her number one loss of energy. It'll be heat. I gotta take a look at the next one. Number 4. Number 4 says a child of mass of m. Well, let's one of these crazy unknown. See, sitting at the top of the slide, it's 5 meters tall. What percentage of mechanical energy? Oh, and she comes out the bottom at 3 meters per second. H equals 0 here. Assume that she starts at rest. Speed at the bottom. Okay, let's find out the energy then. It says, what percentage of mechanical energy had the child had at the top? Convert to kinetic at the bottom. Okay, so we can get EG at the top. There will be no EK, so EG would just be MGH. I'll leave it M as just an M. So 9.8 times 5 is 49. M, just like math class, it's an X, but that's just going to be an M there. At the bottom, this was at the top. And that's also E total, because there is no EG. At the bottom, my E total is going to be 100% EK, which we can figure out to be the mass, 3 squared all over 2, which equals 4.5 M. Okay, if we had the mass, you could put it in. If you want to just make up a mass, you could just say it's 1. And it'd be 49 joules for each kilogram of kid, and it'd be 4.5 joules for each kilogram of kid at the bottom. Okay, but they said, what percentage was converted to kinetic? So you could just do percent, would be 4.5 M over 49 M times 100. M's cancel out. 4.5 divided by 49 times 100 is 9.2%. 9.2% of the energy got converted to kinetic. What feature? Okay, so they're going to say, where did it go? Same thing as before. It turned into heat. It's from friction. Okay, so the kids don't fly off and get hurt at the bottom. Okay, number 4. Last question here. A boy fires a 60 kilogram pebble with a slingshot. Leaves the slingshot at 35 meters per second, high above the slingshot rise. If it's straight up, I was going to shoot it straight up. So here's question 4. Here's something that's going up at 35 meters per second, and it's 60 grams. Okay, that's it right there. And it's on the ground. So H equals 0. So we got the 2 things. My E total, I get it right at the beginning. But let's see what they said. How high will it go? Okay, let's get E total. EG plus EK. We're on the ground, so that guy's a 0. The mass is 0.06. Velocity is 35. Squared divided by 2. That'll give away energy, 35 squared. 6 divided by 2. I got 36. Whoops. 36.75 joules is my total energy. At the highest point, let's take a look at question A now. At the highest point, we're significantly up in the air, but our velocity has dropped to 0. And we're looking for that one. So E total, which would be the same as that number, will be EG plus EK. And you know you've come to a stop at the highest point because you're turning around to come back down again. So 36.75 equals, EG is going to be the mass times 9.8 times the unknown height. Now I multiplied by 0.06 to get this number. I'm just going to divide by 0.06, divide by 9.8, and we get a maximum height 62.5 meters. Okay, and it said, if the pebble is fired so that it has an arc. Okay, let's continue this question below then. It's going to have an arc, so let's take a look at B. It's going to come off here at 35 meters per second from the ground, same as before. I'm just going to launch this way, and at the top here it's going completely sideways at 10 meters per second. And they want to know the height. Okay, same thing as the other question. I have to find E total. It's the same speed, so E total will still be the same number. We got up here, 36.75 joules. Finding this spot here, E total will now be a sum of the 2 energies. Those 2 added together, so E total is 36.75. EG will be the mass, which is 0.06 times 9.8 times the height, plus the kinetic energy, which would be the mass times 10 squared all over 2. Let's get this number. We can multiply that out too. 0.06 times 9.8 is 0.588 H plus 0.6 times 10 squared, which is 100, divided by 2 is 3. So subtract the 3, 36.75 minus 3, and divide by 0.508. Height comes out to be 57 meters in the air, from straight up. And then question C. C says, at what speed would an 80-gram pebble have to be fired to reach the same height as the pebble in A? Assume the 80-gram pebble is also fired straight up. Yeah, it's the same. Same speed, same height. So C will be 35 meters per second also. Okay, but if you have a heavier rock in your slingshot, you will have to pull it back further to give it more energy, because it'll take more energy to get the heavier rock to speed. But once they're going at the same speed, they will go the same distance.